In this video, we'll be talking about both one-sided and two-sided limits of functions from a graphical perspective. We'll do this by, if you take a look here, we have a graph of a function, a piecewise function, f of x. It consists of this parabolic curve here and this linear function here. Now, what I'm going to do is first concern myself with the limit as x approaches -1 from the left, meaning here's -1. I'm going to start over here on the left side, and how I teach my kids is I have them imagine that there's a guy walking on that as like a road, and as he from the left-hand side approaches the value where x is -1, you'll see he approaches the value for y of -2. Therefore, the limit as x approaches -1 from the left of the function f of x is -2. Now the other one-sided limit, if I take a look at, again, here's where x is -1, I'm going to approach it from the right-hand side. So here I have someone on the right-hand side of -1 approaching its value. And if you follow his trail here, you'll also notice he does approach a value. The value he approaches is the y value of 2. So I can say that the limit as x approaches -1 of f of x from the right-handed side is 2. Now the question we need to ask ourselves to determine the double-sided or the two-sided limit is, does the person walking on this road meet with this person approaching from the right? And the answer is no, they do not. And since the value of the limit from the left does not equal the value of the limit from the right, we can say that the two-sided limit, or the limit as x approaches -1 of f of x, is undefined, or you could say does not exist. One of the idea I want to bring across is the idea of the value of the function. So we've done the limits, the left-handed, the right-handed. We've determined that the double-sided limit does not exist. What about the value of the function at the value of x -1? Well, so I'm going to go here to -1. I have a value here, but I really don't. I have a hole, so I'm not going to concern myself with that. I do, however, have a solid dot here. Therefore, the value of the function f of x at -1 is 2. Second graph. I have a graph of another piecewise function, g of x. This time we will concern ourselves with the limit as x approaches 1. From the left-hand side, again I see my man traveling on the road, and as I follow his path, as x gets close to 1, his y value approaches 1. So my limit as x approaches 1 from the left of g of x is 1. The right-handed limit, I follow the path of the man walking on the right-handed side of the curve, and when he approaches 1 from the right-hand side, he also approaches the y value of 1. So my limit as x approaches 1 from the right-handed side of g of x is also 1. Now what differs from this graph from the last one is that in this case the guy walking on the road or the path from the left and the guy walking on the path from the right, they do meet up at that same point. So since the left limit is 1 and the right limit is 1, I can say the two-sided limit, or the limit as x approaches 1 of g of x, is 1. Again, examining the value of the function g of x as x equals 1, I'm not worried about as it approaches 1, but as it equals 1, so we disregard the whole, and I see this solid dot giving me a functional value for g of 1 equal to 3. Our last graph, again, we're going to approach a limit. I want to look at the limit or examine the limit as x approaches -2. From the left-hand side, I see that we are approaching a y value of 3 as x approaches -2 from the left. From the right-handed side, I see that we are approaching the y value of 3 again as x approaches -2 from the right. So what I have here is a case where both the left-sided and right-sided limits, again, both equal the same number. Hence, The two-sided limit as x approaches negative 2 of h of x also exists, and it exists at that same value of 3. Finally, to examine the value of h of negative 2, I go here at negative 2, and all I have is this hole. There is no solid dot. There is no point. So what I have is I approach this value and I approach this value, but there actually is no value at x equals negative 2. So I would say that the function h evaluated at negative 2 is undefined.